Hello, welcome to lecture 1. This is James, and this lecture is about AP, right? So I would majorly focus on the differential calculus, but I'm going to talk about also on the lines of integral calculus as well. So first, for those people who have encountered me in different lectures, you already know my introduction, so you could skip some of these parts. But for those people who are unfamiliar with me, my name is James. So James Yu. Well, James Harim Yu. So this is my name, and the profile that I have, you would read on the website or anything. And I'm gonna talk about this conceptual lectures on focusing on the real test in this case. So AP, so here's a big difference that I have for my classes. So AP BC, well, I want you to take this look at this two different lectures differently. So AP BC it's kind of advanced level. So so you could consider it as a practice material. It's not a practice material, but you could expect to have those types of levels in levels of lectures on college. So this is kind of pre-college lecture, not just for math, but like conceptually or anything. And I haven't really dealt harder than college, so I would say pre-college. And this is something like just directly getting into high school kids, right? And so you must be high school kids, like 9th grade or 10th grade, or whatever you are, whatever grade you are in. This is directly for high school, so I'm gonna make it, I'm gonna make it easy as possible, but not really easy. So I'm gonna make sure that you will get a 5 out of 5. 5 out of 5, like BC that I did, but BC is like 90% 5. So if you listen to my BC lectures, you're gonna get 5 out of 5. That's automatic, but this is more prone to getting 100% 5, so that you wouldn't really miss anything. So that after you are getting into a college, what happens is that you forget everything about integral calculus or even differential calculus. But if you do understand integral calculus, well, most of the things in econ or somewhere else, I say, like business, they are talking about integral calculus, measuring something. So if you're doing well in this BC lectures, if you do understand well enough, you're fine. If you're not, well, AB will be completely different from a different format from BC, because it's not completely different. Level-wise, it'll be easier and easier, and you wouldn't really feel hard or difficult listening to my lectures. All right. So, end of my intro, I guess. I looked at Princeton. I looked at Princeton Review. I looked at Barron's. I looked at Kaplan, and I looked at the real test. And as I looked at it, 15 years of questions. And what I noticed was that they're just asking the same question over and over again. So what it means is what I mean by that is that they're using the same concept. Well, they don't have any addition of concept. They're deleting the concepts, and they're making it easier and easier, so that the test itself, it loses the power of differentiating people who are good at math and who are not good at math. But I hope you're getting 5 out of 5. So my target is that you will finish your test, a 90-minute test, within 60 minutes. That's my target, and you'll get 5 out of 5. So after you listen to these conceptual lectures, if you listen to my application problems, or if you just take any of those practice tests outside your outside this website or whatever, just like, you know, that is floating around the internet. If you are solving those questions, well, I guarantee you will get a 5 out of 5. All right, so enough explanation of my little gibberish. Let's get into a real stuff, I guess. So we want to talk about differential calculus in this course. Right, differential calculus, and usually, well, I would also focus on integral calculus a little bit. I would talk, but I wouldn't really prove anything because I proved it. Well, I didn't prove, well, here's the thing. I'm not going to prove any of those big theorems except something like mean value theorem or intermediate value theorems, because they are important. And if you are planning to take at least, you know, AP math, well, just don't think that, you know, after I got like, you know, 75%, I'm done, right? That's like for people who are going to medical school or who doesn't even have to take any math class. But most of you have to take math after you get into college, especially those people who are targeting for engineering school. You have to grasp the meaning of calculus. So, here's the thing, my lecture will be majorly focusing on differential calculus, but integral calculus for those questions which are targeted for B, well, they are mainly in my series integral calculus lectures, but some of those questions like area, like, you know, area, well, let's say approximation, Riemann sum. I think AB doesn't ask anything about conceptual understanding of Riemann sum, but they definitely ask you a question about a question about right-hand approximation, whether you understood trapezoidal rule and those type of stuff. But most of the things are dealt like in deeper levels in integral calculus lecture series of mine. So for those people who are willing to take those classes, you know, just take those lectures, please do that. But differential calculus, it'll be more prone to give you a technique of derivatives, and, you know, not majorly focusing on the just like understanding of the matter. All right, so differential calculus. All right, so who made calculus? I always begin my lecture using the maker, the creator of this calculus, right? Why? Because usually we have to understand what calculus is. So especially differential calculus, we're talking about the study of change. We're not talking about study of area or study of approximation. Well, approximation is integral calculus. Differential calculus is the study of change. So that's why what you're going to learn is something called limit, and you're going to learn continuity, and you're going to learn differentiability, and you're going to learn something about, well, related rates or those applications. So basically application. So most of the applications that you might see would be related rates, optimizing something. So related rates would be, you know, it's not that hard, but I hope you are getting the gist of it, and I'm gonna make sure that you understand that perfectly. And limit, well, limit, what is the limit? Why do you need to know about limit? Well, Newton said this type of stuff. Newton is the creator of calculus, right? Well, not really. Well, calculus was even in ancient Greek, and in Archimedes, you know, was using an idea, something called exhaustion. So he's exhausting. So what it means is that Archimedes tried to get the area of the circle. So in that ancient time, let me just like give you a briefing about this history. Ancient times, when they're talking about something called calculus, well, they didn't have the name, the subject called calculus, but they did have something called, like, you know, approximation and stuff.